Hi, Assalamualaikum and salam sejahtera. In this video, we will talk about the Voltaic cell and then I will explain about Daniell cell. We have two types of cells, simple Voltaic cell and then Daniell cell. I will explain the concept first and then we will look into the example for both type of cell. Okay, so let's start. Before we start on the experiment setup of apparatus, let's look at the concept for simple chemical cell. Simple chemical cell consists of two different metal that dip in electrolyte and connected with connecting wires. So ada three characteristic of simple chemical cell, which is they must use two different metal. So you can use any metal inside the periodic table. And then you must use an electrolyte. Okay, for those who haven't read about electrolyte, electrolyte is a substance that can conduct electricity in molten or aqueous state and connected with connecting wires. So the connecting wires is the wires that connect between the two electrodes. It also known as Voltaic cell or galvanic cell. Okay, the simple chemical cell are also known as Voltaic cell or galvanic cell, and it changes chemical energy to electrical energy. One of the way that we can produce an electrical energy is by changing the chemical energy to electrical energy. The reaction that occur inside the cell is called as redox because there is a transfer of electron that produce current. And the current will be determined by the reading of voltmeter. So voltmeter is actually used to see whether ada electrical current flow inside the cell or not. So let's look at the first example. So this is the setup of apparatus for simple Voltaic cell where you have two different metals. So in this case, we are using the magnesium and copper metal. And then you have an electrolyte. Okay, the electrolyte that we use here is copper sulfate solution. So this is the electrolyte. And then we connect the electrode with a connecting wire. So this is the connecting wires that connect between the two electrodes. Okay, so dia ada tiga syarat tadilah. Two different metal, one electrolyte, one connecting wires ataupun a connecting wires lah. Okay, so let's look at what happened in the simple chemical cell. Okay, before we talk about how the metal release or accept electron or the ion accept electron, let's look at the E value for both metal. Okay, so this is the standard electrode potential value for magnesium and copper. So if you look at the series, we are arranging the E value according to the negative value first and then followed by the positive value. So as we already discussed in the previous video, so going down the series, okay, the metal will become stronger oxidizing agent, and going up the series, the metal is strong reducing agent. So what does it mean by strong reducing agent? Is the metal will easily undergo oxidation. And what does it mean by strong oxidizing agent? Is they easily undergo reduction reaction. So inside this cell, we have two metal. Both of them are metal. So magnesium and copper have a different electrode potential value. So magnesium is more negative than copper. Means that magnesium is a stronger reducing agent. If magnesium as a metal is a stronger reducing agent, means that magnesium atom release electron easily compared to copper atom. So when magnesium as a stronger reducing agent and magnesium release electron to form magnesium 2 plus ion, so magnesium will undergo oxidation reaction. So if I want to write down the half equation for this reaction, the equation will be magnesium as an atom release electron to form magnesium ion. So this is oxidation reaction that occurs. So as the magnesium release electron to form magnesium ion, so magnesium will be considered as the negative terminal of the cell. So dia akan jadi negative terminal. So let's look at the cell just now. So if you look at the cell, okay, the magnesium will become the negative terminal. So I label the magnesium electrode as negative terminal. And if the magnesium is negative terminal, then copper will be the positive terminal. So what happened at the negative terminal is magnesium will release electron to form magnesium ion. The electron will travel through the electrical circuit from magnesium electrode to copper electrode. And what happened at the electrode copper is that one of the ion that exists in the copper sulfate solution will accept the electron. So let me write the half equation for the magnesium first. So magnesium will release electron to form magnesium 2 plus ion. The electron travels through the circuit and the magnesium ion will form inside the solution. So the magnesium will dissolve in the copper sulfate solution as an ion. What happened to the electrode? The electrode will become thinner. The electrode later will become thinner because from atom, the electrode will form an ion. So we'll find that the electrode for magnesium become thinner. So after the electron being transferred through the copper electrode, so you must look at what is the ion that will accept the electron released by the magnesium atom. So in order for us to do that, we have to look at the electrolyte used in the chemical cell. So inside the solution, you have copper sulfate solution. So let's look at what we have in the copper sulfate solution. So copper sulfate solution contain copper 2 plus ion and also sulfate ion. And then you have water inside the solution. So you have hydrogen ion and also hydroxide ion. So now you have 2 anion and 2 cation. So this is called as anion. Anion is a negative ion and this is cation. So cation is positive ion. So which ion do you think that will accept the electron? So the one that accepts electron must be the positive ion, because if the ion is already negative, it will not be able to accept any electron anymore. So the choice is between copper 2 plus ion and hydrogen ion. So which ion can accept this electron? So we have to refer this to the standard electrode potential value as well. So let's look at the standard electrode potential value for copper 2 plus ion and hydrogen ion. Okay, so this is the standard electrode potential value for hydrogen ion and copper 2 plus ion. So now we are referring to the ion, this one, the ion for the aqueous solution. So according to the E value, so the positive value will be lower than the 0.00 volt value for the hydrogen. So going down the series, we have a stronger oxidizing agent, and going up the series, we have a stronger reducing agent. So now we are looking at the ion, okay, not metal. Tadi kita tengok metal. Now we are looking at the ion. So for copper 2 plus ion and hydrogen ion, we want a stronger oxidizing agent to accept electron. Okay, why? Because oxidizing agent will undergo reduction. And as you know, reduction reaction means that you are accepting electron. So in this cell, we want a stronger oxidizing agent. So which one is stronger oxidizing agent? So obviously, copper 2 plus ion is a stronger oxidizing agent. So when copper 2 plus ion is a stronger oxidizing agent, so what happened in the cell is the copper 2 plus ion will accept electron easily compared to hydrogen ion. So copper 2 plus ion will accept the electron and undergo reduction reaction. So the half equation for copper 2 plus ion here is Cu2 plus 2 electron to form copper atom. So it will change from ion to copper atom. So this is why inside the cell just now, so it's not the hydrogen that accept the electron, it will be the copper 2 plus ion. It is because copper 2 plus ion is a stronger oxidizing agent and accept the electron easily compared to hydrogen ion. If you look at the cell now, so you have two cation there that attracted towards the copper electrode. So now you have the copper 2 plus ion and the hydrogen ion. So between these two ions, one of them will accept the electron, and we have decided that the copper 2 plus ion will accept the electron because it is a stronger oxidizing agent. So we will take the copper 2 plus ion in the solution as the ion that being discharged. Okay, so what happened is the copper 2 plus ion will accept electron to form copper atom. So let me write down the half equation. So the copper 2 plus ion will accept 2 electron to form copper. So in this reaction, copper 2 plus ion will change from ion to atom. So what will happen to the electrode? The electrode will become thicker. More and more copper atom on the surface of the electrode. So it will become thicker. You can also say that there will be a brown solid deposited on the copper electrode. It's just that if we say that the copper electrode become thicker, you can see that the change of the size of the electrode. But if you say that the brown solid deposited, it's quite difficult to see because copper is already brown. So you cannot see the difference on the change of the metal electrode. So this is what happened in a simple cell. There is a redox reaction happen because magnesium undergo oxidation. Okay, this is oxidation reaction. So magnesium here is the reducing agent. So and then at the copper electrode, so what happened is the copper 2 plus ion will undergo reduction. So here copper 2 plus ion is the oxidizing agent. So overall reaction is a redox reaction, and this is how you produce electricity. So when the electron is transferred from the magnesium electrode to the copper electrode, so this voltmeter will give reading. So I will explain again this concept using a Daniell cell. Okay, because this is a very simple cell, so you just want to see whether there is a current flow inside the cell or not. We will discuss on the difference in the potential value ataupun nilai E, okay, the electrode potential value for the cell in the next video.